All right, welcome to the next portion of this curriculum, keys and hashing. So we're going to have a slew of topics that we are going to cover that we need to cover, but because we're resource limited, or at least we don't have the application for it, I'm not going to be able to show you exactly how it works, but we can at least talk about it. And then when the future comes for you, and then you actually need these things at the very minimum. You've heard of it, and then you can research it yourself and implement it yourself. And one of the things I do want to talk about right now is that your technology career is very much based on research and then implementing. It's very rare that you know exactly what to do. Especially if you're trying to do something new, because even something simple or reasonably simple like groups and users, you can be applying that in a particular way where it is a little bit more confusing than what you're used to, or it presses on knowledge that you haven't used in a while. So technology in general, no matter if you're networking or programming, is mostly about problem solving. And if you come in with a mindset of, well, I was supposed to be taught this and I already know it, or I should already know it, or I shouldn't have to research something, you're not going to make it as a network admin or as a developer. So with that in mind, embrace the fact that there are going to be some things that you don't fully understand, and then also embrace that you can also learn. So that requires research, of course, but a little bit of time and effort goes a long ways. So with that said, let's get into the lecture real quick. Okay, so cryptography. All right, so cryptography in general is, most people are going to call it securing data. I would much rather have you think of it as obscuring data. There are a couple algorithms out there that have not been cracked yet, so in theory maybe that is considered secure, but it's only a matter of time before it is cracked. The reason why I'm pressing on this point is because your presentation and your interactions with particularly your business counterparts or clients or anyone else that's not technical, they are not going to understand the difference between obscuring and securing data, and more importantly, they don't want to hear that it's not secure, especially when people in the past over and over and over and over and over again have told them that it's secure simply because it's encrypted. Okay, so that's one thing you really need to separate yourself with in terms of conceptual knowledge, is that cryptography is a way of obscuring data, but everyone in the world is going to call it securing data. So with that said, encrypted data is also known as ciphertext. And there's two types of encryptions, or two types of keys. There's symmetric and then asymmetric. So we're going to go over symmetric first. Okay, single key, single private key. It's a little bit easier to manage, but in general, this is not going to be used, and it's because of the downfalls of it. One is, if this key is compromised in any way, all the data that you have that was used to encrypt it, the key that was used to encrypt that data, it's gone, right? That is compromised. So now you can obviously re-encrypt it, and then you have a new key, but it is hard to secure a single private key. So this is not a good solution to, well, any type of cryptography. So the next thing that we're going to talk about is what we typically use is asymmetric cryptography, which is two mathematically related keys. One is a private key and one is a public key. The public key is given out. This is how you actually access something. So if we're talking about encrypting emails, the public key is the one that you, as someone that didn't have that key, is going to use that public key to decrypt someone else's private email that they used their private key to encrypt with. And hopefully that made sense. Okay, private keys are kept on the device. If you're talking about enterprise devices, then it might just be on a key server, domain controller, something along those lines where you have access to it through the network. Intranet, not internet, right? So you gotta keep it in a secure environment. And then there's a handful of algorithms out there, and the one that's not on here and should be is AES. Okay. I've already rambled on a little bit about this, about where keys are stored. For the most part, it's going to be on either a private network, a private computer, and then your public key is going to be stored anywhere that you give it to. So most of the time it's to another person, but where they store that public key is up to them. So it could be anywhere. So the other things that we need to talk about, because we've been talking up to this point about PKI for the most part. So cat cards are a thing too. So when I was in the military, I had a cat card. I had a bunch of PII on there, private identifiable information, and then TPMs, which is a topic of conversation lately because of Windows 11. They're pushing a TPM for your devices. Apple did this a while ago with their MacBook Pros. It can be stored in files, and then token devices as well, like near field communication, little token things. Okay, PKI, public key infrastructure. This is the one that I'm going to show you in terms of the PowerPoint itself. We're not going to implement it in our network just because we don't really have a use for it, and I don't really have a way of showing you how it works without being extraordinarily academic. Okay. Okay, so PKI components, the big one is your CA or your certificate authority, and this is going to be someone like a Microsoft where they're going to certify that yes, you do exist, and that you can have this certificate stating that you actually do exist and that you can be trusted. And this is mostly a website thing. And if you're talking about web servers and web servers that are encrypted and secure, so your HTTPS, this is part of the procedure. You have to have a certificate that is signed by a CA. The next component is your registered authority, subordinate of the CA, used to manage your certificates. Okay, CRL verifies your certificate validity. Your template is exactly what it sounds like. Okay, this is useful for things like encrypting email. So when you get a new employee, you can give them a new public key. Right? You get a template there. So certificate, and then the certificate itself is going to be the subject name, the signature, the CA. So again, someone like Microsoft, the expiration, and then public and private key info, whatever that may be inside of that certificate. So moving on, TLS versus SSL. This is a relatively important conversation simply because a lot of people still say SSL when they mean TLS. So SSL is deprecated mostly because of Heartbleed and other bugs, but the Heartbleed was the big one. And if you have the opportunity to replace it, you should. 1.1 TLS on modern browsers is supported. Most of them support 1.2, and then because TLS 1.3 is relatively new, is not as supported, but it will be as time goes on. Here we go. And now we got to talk about hashing. So the difference between a hash and an encryption is the intent. So a hash is a technique to make sure that the data that you stored is exactly how you left it. So this is what a lot of our, like ZFS uses for a file system to make sure that the data on the disk is not corrupt from something like a disk rot or just corruption in general. Occasionally that happens over time. Same thing with your ECC RAM bit flips. This is how they figure out Okay, this data is a little bit different. Let's go ahead and fix this based on the checksum that we had. Okay, so but overall, hashing is a way of making sure that data is exactly how you left it and it hasn't been altered in any way. Hashing algorithms, you're going to find MD5 quite a bit. That's what a lot of people essentially use. But SHA-256 is the current standard. All right. And this is where we're going to go over, hey, this is how you install the Windows PKI. We're not going to be doing this on our network simply because I don't have a good way of showing you how it works without being incredibly academic. So we're going to add roles and features. We're going to add it to our domain controller. We're going to add Active Directory Certificate Services. Okay, Certificate Authority. Restart if needed. Configure your directory service. We're going to use the administrator credentials to do this. All right, Enterprise CA for setup type. CA type is root CA. Private key, create a new private key. Okay, yeah, that makes sense. SHA-256, going to use the standard key length. You can pick whatever you want. The bigger the key, the longer it is to encrypt and decrypt. So be careful here if you have low power devices. This can be a problem. All right. Common name, yeah, this is all default, 10 years. Okay, again, makes sense. And that's how you install a PKI environment for Windows. We're not going to be, again, doing that on ours because we don't have any need to. So with that said, that's going to be it for this presentation. We're going to be going over some of those concepts overall in terms of our little mini test that we're going to have throughout the semester. But overall, just understand that your secure environments require keys most of the time, and then depending on what you're trying to accomplish is what you are going to do. So that's going to require some research and possibly some trial and error. So if you don't have a personal environment already, go ahead and set one up, and if you want to practice, go ahead and do so. But with that said, that's going to be it for this one. So I will see you in the next video.